And so the volume of 1 penny is therefore equal to 45.2 minus 45.0, which is 0.2 milliliters. So that's how you use the water displacement method to determine the volume of an object. You want to know how much water did that object displace. And you can calculate that volume of water displaced by taking the final volume of water, subtract it from the initial volume of water, and that gives you the amount of water that was displaced, which is equal to the volume of the object, in this case, 1 penny. And then I'll add another penny to the 1 penny that's already there and determine a new final volume for 2 pennies. Take that new final volume for 2 pennies and subtract from the original initial volume of 45 milliliters, and that gives you the volume of 2 pennies. And then I'm going to add 3 additional pennies to the 2 that are already there, get a new final volume for 5 pennies, subtract it from 45, and that gives me the volume of 5 pennies, and so on and so forth. So you'll see me doing these steps in this series of videos. Also shown here where the videos are, the inquiry set 3 videos. There's an initial volume video for the 45 milliliters and the 1 penny, then 2 through 40 pennies. Videos for each of those steps are shown there. And then there's also a link to a file that just has pictures for pictures that show you the volume level of water in the cylinder after adding 1 penny, 2 pennies, 5 pennies, 10, 20, 40, and so on and so forth. So you have 2 choices. You can watch all of the videos for inquiry set 3, which are very short videos. I don't think they run from anywhere between 1 and 3 minutes long each. So all of these videos for inquiry set 3 are extremely short. I think there's maybe a couple that are not even 1 minute long. So to watch these 1, 2, 3, 4, 5, 6 videos should take you no more than about 6 minutes. Or you can just view the picture files to determine the volume of water, the final volume of water after adding each set number of pennies. And again, there's also a picture as well as a video showing the initial volume of 45.0 milliliters of water. So it's your choice. You can watch the 6 sets of videos and determine the volume of the final volume of water after each set of pennies is added. And you can watch and you can view the pictures of each step as well, or you could just view the pictures. I'm going to let you decide if you want to watch the videos and view the pictures or just view the pictures. Either way is fine. And then after you've watched your videos and viewed the pictures and you've determined the volumes after adding each set of pennies, then you'll be ready to go into your group meeting rooms and answer inquiry set 3 questions. And so the videos and picture viewing process should take you no more than about 10 minutes to do. And then you'll want to get with your group and answer inquiry set 3 questions. So let's meet back in the meeting room at about 10:55 a.m., no later than 11.
Dr. Cook, I have to switch over to my phone, the Teams app on my phone, because I'm driving.
Okay.
I can pull over and switch to my group, but it's saying that I'm going to have to end the call. Like on my Mac, it'll just let me switch over.
Okay, if you can't get into your group room without ending the call,
Uh-huh.
then you may want to just stay in the general room for this set of
Okay.
questions. If that's going to be an inconvenience, being that you're driving, I would say put your driving and your safety priority. If you
Okay.
can't
Thank
go
you.
into your group meeting room, just stay in the general room.
Okay.
And so what you're saying, you can't watch, you can't watch the videos
I've been
on,
able to watch all the other videos except for these.
okay,
I have to go to work.
okay. So I would say you may want to just stay in the general meeting room if you can't watch the videos,
Okay.
or you may just want to try to download the pictures.
Okay.
Okay,
All right. Thank you.
you're welcome. Okay, we are back in the general meeting room. And so I'm just going to run through the pictures and or videos that you should have viewed for inquiry set 3. So this is the volume of 1 penny, final volume in the cylinder after adding 1 penny. Let me clarify that. So I estimate this to be 45.2. Is there anyone that disagree or anyone that came up with a different number? So if after adding 1 penny, we have a final volume of 45.2, and I added an extra decimal, an extra 0 at the end. You can do the same. Our initial volume was 45.0. So therefore, if you subtract 45.20 from 45.0, you get a volume of 1 penny of 0.20. Now this is a picture after adding 2 pennies. And so I estimated this one by reading the very bottom of the curve. I estimate that to be 45.4. And so with the final volume being 45.4, subtracting from the initial volume of 45, you get a volume of 2 pennies of 0.40. And then for 5 pennies, so we know we have somewhere between 46 and 47 milliliters for our final volume after adding 5 pennies. So what was your estimate of the final volume after adding 5 pennies? Anyone want to share?
46.30.
That's a very good estimate. Anyone else have a different number?
I said 46.50.
That's also very good. I'm going to be very lenient. Like I said, it depends on the viewer who's reading the cylinder. So long as everyone has a logical value, you're going to be fine. So therefore, if we do the subtraction, (46.5) minus 45 gives us 1.50 for our volume of 5 pennies. Or 1.30 if your final volume was 46.30. So after adding 10 pennies, what was your volume reading? I read that as exactly 48.0 by reading the bottom of that curve of the top layer of the liquid. So my estimate was 48.0 after adding 10 pennies, giving me a volume of 10 pennies of 3 milliliters. Then after adding 20 pennies, I did an estimate of 51.8 by reading the very bottom of the top curve. You may see that at exactly 52.0, but I see it as a little bit below that 52 line. So I estimate about 51.8. And do the subtraction, you get 6.80 milliliters for the volume of 20. And then the last picture, after adding 40 pennies, so I see it's between 58 and 59. And reading the bottom of the curve, I estimated about 58.5. And giving you a difference for volume of 40 pennies of 13.5. Any questions or concerns about our data? And again, yours can be a little bit different than this based on how you read the cylinder, but they should all of us should be in pretty close agreement with each other. So now we've got the values for volume of 1 penny, 2 pennies, 5, 10, 20, and 40. And so the way we were supposed to answer the inquiry questions for set 3, pretty much the same way we answered them for set 1. The answers for A, we want the volume of our reading with 1 penny, and I think that was 0.20 milliliters. And then we're going to answer B through F the same way we answered B through F for data set 1. The answer is going to be yes to all of these. Yes, we can use the volume recorded for 2, 5, 10, 20, and 40 pennies to get an average of the volume of 1 penny. So for the volume of 2 pennies, think I got 0.40. And so we just take that number and divide by 2. And then we just repeat this for 5, 10, 20, and 40 pennies. And so now that we've answered A through F in the same way that we answered A through F in set 1, then you'll answer question G the same way as we did for question G in set 1. Are the numbers exactly the same? Well, some of them are. For sets 5 penny and the 10 penny sets, the volume of a penny is the same, but and also for the 20 and the 40 set, the numbers are the same. So are the numbers exactly the same? Not all of them, no. But are they close to each other? Yes. The sets I say the sets 5 pennies through 40 are very close. The 2 penny set is a little bit of an outlier. It's only 0.20 milliliter average for a pen volume for a penny. Whereas for the other sets, you're in the 0.3 range. And so we can do the same thing to determine how close they are to each other exactly. We can get the average of averages. We take these 5 averages, add them together, and divide by 5. Add those averages together and divide by 5. You get the average of averages. So we round to 2 decimal places. Our average of the averages is going to be 0.30 milliliters. And then we can do the deviation from the average of averages by filling in this little chart. And then the average of averages is 0.30. So take 0.30 and subtract it from the average. And you can see that these are very low deviations, where this one is a moderate. So the 2 penny set is a nice deviation from the average, but the others have very, very low deviations from the average of averages. So are the numbers close to each other? You can say that data sets for 5 pennies through 40 pennies are close to each other, but the 2 penny average is not close to the others. So we would call that, in mathematical terms, we would call that an outlier, because that one is a little bit farther away from the others. And then again, which is going to be the best volume of a penny? We would answer that the same way we answered question H for set 1. So are there any questions about data set 3, the data itself, as well as the inquiry questions? We are done very early, so there's plenty of time for questions if you have questions.
Do you want us to write this deviation chart up?
That would be a nice extra to explain your answer as to are the averages close to each other. This would be all the explanation I would need to tell me if these averages are close to each other or not. I can see that the first one deviates from that average of averages much more so than the sets for 5 through 40 pennies. So this would be a great way to answer that question rather than answering it in sentences. And this also answers the questions, are the numbers exactly the same? I can see right there that some of them are, some of them are not. So the way that you could answer question G would just be this data table would answer that entire question. Any other questions? So which one did you say was the best volume average for 1 penny?
I got 0.35 for mine.
So that was your average volume for 40 pennies?
Yes.
I agree. So whatever your average volume for 40 pennies was, that's going to be your best estimate because it's the largest data set. Any other questions about data set 3 or the inquiry questions for data set 3? And then make sure that on your data sheet, data tables, that you fill out your answer for step 33. Mine was 0.34 milliliters, yours may be 0.35, so on and so forth. So make sure your data tables are filled out completely. Make sure you include your name and your partner information. And then also make sure set 1, 2, and 3 inquiry questions are answered completely. You have until 11:59 p.m. tonight to get your report sheets uploaded to the Dropbox. Make sure you have your report sheets compiled into one single .doc or PDF file. And if you have any questions between now and midnight tonight about the lab report, just send me an email. If you want to go ahead and leave the meeting, we are technically done with the lab, but there is still plenty of time remaining if you have further questions. If you don't have further questions and you're going to leave the meeting, have a great weekend. I'll see you in class on Monday if you're in class with me. If not, I will see you next Friday.